Okay, so let's begin with the exercise once again. So the initial cost of the system is $425,000. The depreciate rate is 12%. And in the table, you will see the total amount of cash inflow and the outflow. And we are supposed to do the following. Now, just going back, we had disconnected 2 times earlier due to some technical glitches. So those of you who have already calculated the present value, the cumulative cash inflow and the cumulative cash outflow together with the present value of cash outflow, thank you. Keep your answers in there. So as I will be going by, I will try to get these done again. So in our Excel spreadsheet, so I will write down again initial cost of the system. And I need to put it down, the value in a new cell, just to pick up the cell references later onwards. Moreover, the depreciate rate is 12%. Depreciate. Now, the depreciate rate, sometimes it may be labeled as discount rate. Sometimes it may be just written as rate. So if it's any of those 3, you should know that that's the discount rate. In fact, there is, in this kind of questions, in payback analysis, you only have one of the rates, okay? So I'll quickly go and copy the entire of these and paste it in here. So this is what I have. And I will try to adjust this accordingly. So this will be $425,000 without any spaces, $495,000 without any spaces, and likewise same thing here. Ensure that you do not have any space. Now we did try it out last week with the spaces, it didn't work. So we need to be very accurate in terms of maintaining that there is no space in between these values. So let's go and insert the commas in there so that it is able to make things more better for you to recognize that it's 495,000 and not in millions. Okay. Likewise, we'll do the same for the outflows. So we'll remove the space and the comma, and then we'll insert it later. So this space in here again. So I will go and align all these to the left-hand side. So my left alignment, okay, button, and need to ensure that there's a comma. So Janesh, thank you for connecting with us again. My apologies. I was facing some technical difficulties. Now things are back to order, so bear with me. Thank you. And also at the same time, what I'll do is you'll notice that your decimal points, some of them has a single 0, some of them have 2 zeros. So we'll remove the decimal points for this exercise at the moment. Now, first of all, we are supposed to find out the present value.
Excuse me, sir, we are not able to see the screen. See, we are just seeing the model.
All good now?
Yes, now good.
Okay, thank you. So first of all, what we are going to do is we will actually go and try to find out the present value. To calculate the present value, the formula is cash flow divided by open bracket. In fact, let's have 2 brackets. Why 2 brackets? I'll just tell you in a while. Plus R is the rate, and then to the power of T, and then close the bracket. Now, do notice this. 1 plus R is a separate calculation of its own, and then the value that you get here to the power of time, T is time, is another separate calculation of its own. So that to make things easier and accurate, we're using double open brackets, and then we're closing it twice. Okay. So the present value inflow for year 1 is 0. So we'll still apply now our formula. So it's equals to your cash flow. At the moment, it's nothing. And then divide by double open brackets, and then 1 plus rate. So 12% is equivalent to 0.12, close the bracket, and then to the power of time, which is year 0. I will select the cell reference so that later onwards we can apply the shortcuts in there. Close the bracket, press enter. Now, why I'm getting a value error is because of the dash, so I'll replace this with 0. So that's what you get. And once you get your answer, select the cell, find the precision point, the small tiny box that you see here in the corner, and then pull it across. And these are your present values. Now do note that your answers are in 4 decimal places. Let's reduce it to 2. So decrease decimal button, place a click on it twice, and you should be able to remove them. Now I will change this font to Calibri and have a font size of 15. Okay, next up is cumulative cash inflow, which is equals to, so how do you get your cumulative cash inflow? So the present value here for year 0 is just 0. Next up, for year 1, the cumulative cash inflow is equals to the total cumulative cash inflow for year 1 plus the present, well, for year 0 rather, plus the present value for year 1. So it gives you a total as such. Likewise, next is your cumulative cash inflow for year 2. So cumulative cash inflow for year 1 plus your present value. Again, for year 3, the formula, cumulative cash inflow for year 2 plus present value for year 3. For year 4, cumulative cash inflow for year 3 plus the present value for year 4. And finally, for year 5, your cumulative cash inflow for year 4 plus the present value for year 5. So this is your total so far, and I will have this in bold. And let's add in the commas. Great. All good, everyone? Now, at the same time, we'll also go and calculate the cash outflow. Now, just like I mentioned earlier before we disconnected, sometimes you will not have the initial cost of the system in year 0. So just in case if it's not there, please ensure that you have to add this manually. Okay, so equal to, and this is the value, press enter. So the present value for cash outflow is equals to, okay, your cash inflow, so your cash flow value, and then divided by double opening of the brackets. So 1 plus 0.12, why 0.12? Because our discount rate is 12%. 12% is same as 12 on 100, therefore 0.12. Close the bracket to the power of the time, which is 0, and then close the bracket once again. So this is the value, find the precision point, and then drag it across. Now you get an error over here. Let's go and remove this comma. No, 310,000, there you go. And this is your total cash outflow. And we have some formatting to do. There you go. Likewise, for my printer, I will have this. Now to find the cumulative cash outflow is equals to the present value for year 0. This is what you get. And then finally, your cumulative cash outflow for year 1 would be cumulative cash outflow for year 0 plus the present value. Again, the cumulative cash outflow total plus the present value for year 2. Next up, to find the cumulative cash outflow for year 3 will be cumulative cash outflow for year 2 plus the present value for year 3. Next, for year 4, cumulative cash outflow plus the present value for year 4. And then finally, cumulative cash outflow for year 3 plus the present value for year 5 gives you a total as such. So I will basically go and do a format painter, so it copies the same format, and these are your values. Is there any questions, any queries from anyone so far? No? Okay, if no questions and no queries, now this is what we have done so far. We have found out the present value for both cash inflow and outflow. And then we have calculated the cumulative cash inflow. Now, why are we doing this? Let's have a look at the question on Moodle. And the question says, calculate the net present value. So if we want to go and find out what is the net present value in this case, this is our formula. So net present value is equals to cumulative cash inflow minus cumulative cash outflow. Now, do notice this. It says cumulative cash inflow. Now, all these values are cumulative cash inflow. So which value are you going to take? What do you think? Sharat, which value are we going to take from here?
The final amount?
Yes, the final amount, the total. Now remember, what happens in questions like this is when you are looking at the net present value, you generally end up calculating for the lifetime of that particular system. Okay, now it does not necessarily mean that the system will only, that the organization will only employ the system for 5 years. It can be more than that. It can be 15, it can be 20. But what happens is that the organization would normally work things out according to a long-term plan. So when we say a long-term plan, we have gone over this in our lecture notes. A long-term plan is just like saying it is a strategic plan. So as per the strategic plan of the organization, they will try to calculate the total inflow and the total outflow. So with the calculation of total inflows and total outflows, we get the value as something called as the net present value. So yes, thank you, Musharat, for your answer. You were correct. So we will take the very last value, that is for year 5, for the total or cumulative means the same thing. Okay, for total inflow minus the total outflow. So therefore equals to your total inflow value minus the total outflow, and you get an answer of $241,883.60. So that is your net present value. So by looking at the value, what do you conclude, or what do you have to say? Whether implementing the system is profitable to the organization, or is it of a loss? Monish, what about your views on this? Monish, you there?
Sir,
What do you think? Is it profitable for the organization, or is it of loss?
say profitable.
Profitable? Yes,
Yes.
it is. Yes, it is profitable to the organization. Thank you. Now, why profitable? Because whatever value you're getting in a positive number. Okay, just in case if a number was negative, then there might be issues that means the organization is going through a loss, and we do not want that. Now, remember, when you're doing CIN603, you are sitting at a position of a system analyst. So you are thinking from that point of view, whereby you want to ensure that the organization sees a certain level of profitability when they are implementing a system, because that's the major reason behind it. You wouldn't want to invest into a system whereby you end up making losses. All right. So yes, the value is in positive. In fact, it's about $241,000. So that's a big number. It's a big amount of money, so most definitely they are making a profit. Now do notice this. Look at the trend of inflow. So you started with 441,000 and then gradually it moved, it doubled up. Do you see that? So it doubled, went up to millions, 1.5 million, now 1.7 million, and eventually it will go beyond 2 million and so forth. So it's bound to bring in more of cash to the organization. Let's look at the next part of the question. It is calculate the return on investment. So the return on investment here would mean is what is the total amount of money that the organization is earning based on the inflow and the outflow of the cash. So the formula is as such. So ROI is equals to, so you have the, first of all, what you're going to do is you'll find out in brackets, okay, let's not include brackets here. You'll find out the profit divided by the initial costs, multiply by 100. Okay, so in this case, your net present value is the profit rate for year 5, right? If I'm not wrong, is it or not? It is. So another way of writing this formula would be net present value divided by the total cost. Sorry, this should be total cost, eh? Multiply by 100. So to calculate that in terms of figures, so equals to your net present value divided by the total cost multiply by 100. So that's 15% of return on investment. That means whatever money the organization has spent, they have achieved 15% of surplus on it. Any questions so far? So take about 5 minutes, everyone, and calculate the net present value and calculate the return on investment. Just in case if you are not able to see the screen properly, pardon me, my computer that I'm using at the moment, it is hooked up to another computer. So so what's happening is just because two computers are hooked up to each other, sometimes I end up facing some glitches. The computer on the other side, there's another person who's using it at the moment. Okay, so just in case if you see any glitches on the screen, do let me know. Okay. So while you're attempting it, if you have any questions, any queries, please do let me know about it. Now do notice this, whatever we're doing, it has a flow to it. When I say flow, we calculated the present value. From the present value, you get our cumulative values. So from the cumulative values, the total of inflow and the total of outflow gives us our net present value. So with the net present value, you are able to find out the profitability rate for the organization. So the profitability rate over the total cost that you have, you multiply by 100 gives you a return on investment. All good, everyone? Shall we move on to the next exercise? Okay, so the next exercise is calculate the payback period. Now, I want you to try this out. It's pretty simple. That's what we had done last week, payback period. So try to compare the cumulative. These are the values that you're looking at. Let me just have this in bold. Okay, so these are the values that you are going to look at. And based on this, please go and find out your total payback period. That means in which year the total cumulative cash outflow may equal to the inflow as well. You have, I'll give you about 10 minutes to do this. So it's 101, 110 should be able to finish up. Okay, so what years are you looking at? So if we look at the total values, which years are you comparing? Anyone?
Year 4 and 3.
year 4 and year 3. Okay, so if you look at the value for year 4 and year 3, okay, have a look at this. For year 1, so your total outflow is 701,000 something, and then your inflow is 441. That means there's still a lot of variance. Okay, so if you look at for year 2, the cumulative cash inflow is 836. Still, it is not able to meet the value for the outflow. Now have a look at this. For year 3, your inflow is 1,188 and your outflow is 1,169. So which one is more, inflow or outflow? Which one is more, inflow or outflow?
Inflow.
Inflow is more. Okay, so which years are you looking at now, Musharraf?
3 and 2.
Yeah, 3 is 2 and 3. Okay, so those are the values. Try them out. Let's see if anyone is able to correctly figure out on which year you are actually able to get the complete payback for the system that the organization buys. Okay, let's work this out. So your year 2, if you look at the value for your outflow, it's $948,915.82. For your inflow, it's $836,575.26. Okay, now these are not the values we are worried about, but we're more worried about the values that you have for year 3. So if you look at the values for your inflow, it exceeds the outflow. That means somewhere in between year 2 and year 3, this is where you get a break-even point for the system that the organization has just implemented. So first of all, let's go and find out the difference. Okay, so to find out the difference, so you will do inflow minus outflow for year 3. So this is a total difference that is between year 2 and year 3 values. Okay, now if you look at the inflow and inflow for year 2 and inflow for year 3, let's also go and figure out how much the organization has able to earn the money within years 2 and 3. So the difference that I would think it would be 495, sorry, not 495, but yeah, this is the value it might be. Let's go and have a look at it. So it's equals to, you have 1.18896.48 million, not divide by, but subtract it with the value that you have there. So you get $352,331.22. So that is the difference. Now, to find out the payback, so it would be is equals to, so the difference between year 3 divided by the inflow within that year multiplied by 12, you get 0.65. Now, anyone got a similar answer as such? Anyone? So in total, that would mean, what it would mean in total? Now, is this correct? People, can I hear from you? Anyone? Are you able to figure out whether that is correct or not? Now, this is not correct. Figure out what is wrong in there. Janesh, are you able to figure out what is your answer, Janesh? Okay, Musharat, you were saying something?
So the yearly benefit?
Come again?
The yearly benefit?
Sorry, I'm not able to get you. Come again,
The
Musharat?
yearly benefit?
The yearly benefit?
Yeah.
It's not correct? Okay, now this is correct. The total amount that you get between a year, this is definitely correct. What about this value? Something is wrong in there. Can you go and cross-check what is wrong in there? Now, at the moment, what I have done is I have subtracted the values for year 3, for inflow minus the outflow. Is that correct?
No.
No, it's not correct. Okay, you're true in terms that it is not correct. So what do you compare with?
Year 3 with year 2.
Year
True.
3 inflows with year 2 outflow?
Yes.
Yes, that is correct. Okay. Now, what about this? Try it out, try it out. First of all, try it out and let me know what is the total payback period. Then we'll go and figure out what we had done wrong or where the correct figures need to be fitted in. This value is correct at the moment. Okay, what about this value?
You should minus the inflow for year 2 and inflow for year 3.
Year 3, okay. So inflow for year 3 minus inflow for year 2. Is this what you're saying?
Yes, sir.
So that means the answer was correct. Now, generally, this is correct for sure. This is correct. Why? Because if you look at the difference between those two values, where is it? Okay, here, year 2, year 3. So this is the difference. 352,331.22. So this is correct. And what Musharraf had quoted earlier is also correct. Now have a look at this. So how do you calculate this? So your inflow for year 3, you need to subtract it with year 2 outflow. So what you're trying to do is you're trying to figure out what is the difference between these two. So once you have that value, which is 239,990.66, so from there, you want to find out what is your monthly income from this value. So to do that, it will be is equals to 239,990.66 divided by this value multiplied by 12. So 8.17, is that what you get? So now if you need to cross check, you can always go and cross check whether the answer is correct or not. Do you still remember how do you cross check? So you will take your yearly income divided by 12. So that's the value that you have. So equals to your monthly income multiplied by 8.17, you get 239,990.66. If this is equals to that, that means your payback period 8.71 months is correct. Okay. Now that is not the correct answer yet. Let me tell you, this is just in months. So therefore, your correct answer would be 2 years and let's make it like this. Payback period is 2 years and 8.17 months. Monish, what do you think? Janesh, Musharraf, do you get the same answer as what I get?
Yes, sir.
Yes?
Yes.
Sir.
Okay, it's correct now? All right, now please try your best not to confuse yourself too much. Why? It's pretty simple. What you're trying to do here is you're trying to find out the total amount you will need to get in order to reach the break-even point. So break-even point is whereby your inflow is equals to the outflow. So your inflow for year 3, you'll subtract it with the outflow for year 2. So you'll get the difference as to what are the varying figures. After that, you'll go and find out the difference for your inflow from year 3 and year 2. So this is what you get. Thereafter, so the very first difference where you found out the difference between inflow and outflow, that value divided by the difference of the inflow multiplied by 12. Now why 12? In a year, there are 12 months. So when you do multiply by 12, you get a value. Now the value that you get would be in terms of months because you're multiplying it by 12. To get the total payback period then, so you'll go and compare because we are saying that the break-even point is reached somewhere between year 2 and year 3. So the total amount of years is 2 years and the value that you have received 8.17 months. That is your payback period. All good, everyone? Now, next up, the next portion, is the investment on the new system profitable? Yes, it is profitable. Why is it profitable? You've got 2 reasons now. In fact, you have 3 reasons. First of all, your cumulative cash inflow is more than the cumulative cash outflow. Okay, how are you able to do that? You can just cross compare it just by looking at the figures, or you can say you have a net present value of $241,883.60. So therefore, your system is profitable. Now, if you want to prove it in terms of percentages, that's where you have your return on investment. So your return on investment is 15%. That means you are able to get 15% more of the returns compared to what you had spent. Moreover, you can also conclude by saying that the investment on the system is profitable because you are able to reach a break-even point or a payback period within 2 years and 8.71 months. All good, people? Now, let's look at the final portion in that question. The system is sold at a value of 1.7 million after the 5th year. Calculate the rate on investment. So what has happened is after the end of the 5th year, so the system is sold. So what is the selling value? 1.7 million. So 1.7 million, you have to write it down properly. Okay. So this is 1.7 million. This is now 1.7 million. Okay. And this is your selling amount. Okay. So how do you find the return of investment on this? So that means the value sold minus your total costs, okay, multiplied by 100. So on what year has it been sold? On the 5th year. So therefore your value here is 1.7 million minus your total cumulative cost for the 5th year is 1.5 something million multiplied by 100. Now have a look at this. You need to place this in brackets. So you have two opening brackets, close off the subtracting value, and then close off the finishing by multiply by 100 value. So what do you get? Pardon me, there's one more thing missing from here. Give me a second. Divided by total costs. Now, this formula is very much same as what you have here. Profit over total cost. So the value sold minus the total cost will give you whether you have achieved a profit or loss, divide by the total cost, multiply by 100. So therefore your value, let me do this again, is 1.7 million minus this value, close a bracket, divided by this value, multiply by 100. Now you need double brackets again. This should suffice. So this would be in terms of percent. So 10.21%. Oh, just to repeat it once again, your value sold minus the total cost, divide by the total cost, multiply by 100. Same formula as this. Over here, you had profit value. Now over here, in this case, you're first of all going to find out whether you're getting a profit or not. It can be a loss. If it's a loss, so there will be a negative value. So wherever you get a negative value, that becomes unprofitable for the organization. Okay. Now I'll give you about 5 minutes to try this out. Should there be any questions or queries, let me know. Well, okay, everyone. Now, any questions in regards to this exercise? Now, we have completed exercise 1 from our week 14 section of the model show. Let's get on with exercise 2. Now, exercise 2 is in form of a case study. So let's read this. Okay. The Tunane biscuit company placed is a successful manufacturer. Since it was established 5 years ago, it has gradually increased its range of plain and cheese biscuits. The sales director has now come to the board with a proposal to expand the range into chocolate-coated biscuits. Now, this involved the purchase of new machinery. The initial outlay will be $135,000. The finance director and the sales director meet to discuss sales projection for the new range of chocolate biscuits. They forecast the following net cash inflow over the 5-year period until the machinery will need to be replaced. Okay, now this is the very same scenario that you are given in your major project. Over here, it is for a machine. In your case, it is for a website. Now, in addition to these inflows, it is expected that the machinery will be sold for scrap at the end of the 5-year for $100,000. Now, what it is saying is that they will buy it for $135,000. Over the range of 5 years, they will get certain amount of cash inflow. In the end of the 5th year, they will end up selling the machinery. Okay. Now, the company's policy is to depreciate machinery on the straight line basis of an estimated useful economic life. Now, you are to calculate the present value for all inflows, calculate the cumulative present value for inflows, calculate the net present value, calculate the return on investment after the machine is scrapped off, and what will be the payback period. Okay, so let's go and work this out. So I'll open up a new worksheet very quickly. Okay, and I will rename this as exercise 2. Show the initial cost of the machine is $135,000. So I'll write down here as $135,000. Okay, now is there any discount rate or depreciate rate over given in this exercise? No, it isn't. If not, don't worry about it. Okay, and then we have these values. So I will quickly go and enter these values in here. So there you go. All right, so this is the cash flow. So we're supposed to find out the present value, the cumulative present value of cumulative cash inflow, and then finally we'll go and find out the net present value. Okay, net present value, let's place it over here. All right, now your formula to calculate the present value is equals to your cash inflow divided by double open brackets 1 plus 1 would be there by default plus, now you don't have a discount rate, so have it 0. Okay, and then to the power of which year is that? Now that is year 1. Now what I will need to do in this case is this. We can modify the table. 1, 2, 3, 4, 5. Looks better now. So equals to cash flow divided by 1 plus 0, and then to the power of time. So that is the very first value. Now you are getting an error. Why? Probably you might need to write this manually. There you go. Next up, your next value Okay, now either you can do it manually for each and every one of those, or you can find the precision point and drag it down. Now, why we're getting it? It's just because of the formatting error. So what you might need to do is you might need to go around and write those manually. $52,000 in this case, 55,000, and then 55,000 here as well. Now we are getting the same values. Let's go and see what went wrong in this. Now that's B5 divided by 1 plus, since there's no discount rate, to the power of A5. This is correct. This changes to A6, A7, A8, A9. Okay. Can you guys try it out and then give me a feedback if the values are correct or not? Take 2 minutes to get it done and let me know. Okay, have you calculated your answers already? The values are correct, right? Now, why do you get the same answer? Is because remember, it's 1 to the power of 1 will give you a value of 1. 1 to the power of 2 would be same as saying 1 times 1 will still give you 1. 1 to the power of 3 is 1 times 1 times 1, that still will give you 1. So anything divided by 1 would give you that anything values. In this case, if it's 35,000 divided by 1 will give you a value of 35,000. If it's 47,000 divided by 1 will give you a value of 47. So these values are correct. Now let's go and find out the cumulative present value. So 35,000 here for year 1, for year 2, it's cumulative present value for year 1 plus the present value for year 2 gives you a value of $82,000. Now year 3, cumulative present value for year 2 plus present value for year 3 gives you a value of $134,000. Year 4, cumulative present value of year 3 plus the present value of year 4 gives you a value of $189,000. And finally, $189,000 plus 55,000 gives you a value of $244,000. These values are indented to the right with a comma. And then I will try to decrease the decimal points. Now, this is your total inflow. So in this case, what would be your net present value? Remember, the net present value is cumulated cash inflow minus cumulated cash outflow. So in this case, is going to be, so we will do an inflow minus, let's put it like this. You can use cumulative, or you can use total inflow minus total outflow. So therefore equals to $244,000 minus what is your outflow. Now, in this particular exercise, we are only given the initial cost. That means there's no other cost associated with it apart from the initial cost. So minus 135,000 gives you a total net present value of $109,000. All good, people? Now, next exercise is we've already found out what is a cumulative present value for inflows. We have already calculated what is a net present value. Now, calculate the return of investment after the machine is scrapped off. That means it is sold for a total of $100,000. Now, return on investment is, in this case, okay, now since you're selling it, so selling price minus cost price divided by cost multiplied by 100. Now, if you look at in your this exercise, we have said value sold minus total cost divided by total cost. Now, why I have written it differently here, selling price minus cost price, and why total cost? Because your total cost here is just the cost of the machine, okay? So that's why, and in this case, the previous example, you had a scenario whereby you had cumulative cost. However, this still would be same as this. The procedure remains the same. So therefore, okay, you have a double opening bracket. So your selling price is $135,000. That's D1 as your sell reference minus your cost price. Pardon me, your selling price is, what is your selling price? $100,000. Okay, so 100,000 minus your cost price, and then divided with the cost price, close the bracket, multiply by 100. So you get a value of negative 25%. So what does that indicate? So after selling the machine, and if you're comparing it with the total cost, you're making a loss of 25%. All right. Now take 5 minutes, try to get this done. All right, moving on, your year 3 and year 4 values. Let's have a look at them. So your year 3 cumulative present value is $134,000. Now we're trying to look at the payback period. Now in this case, your total initial cost of the machine is $135,000. You do not have any extra to the cost added for the next 5 years. So this would be the cost threshold that you're looking at. Now, if you try to compare with the CPV or cumulative present value for the inflow of money, okay, so if you look at year 3 is $134,000, you're still short by another $1,000. And if you look at your year 4 is $189,000. That means somewhere between year 3 and year 4, you are able to get your payback period. So how would you go around doing it? So first of all, you'll find the difference. Now over here is equals to 189,000 minus 135,000. So this is the difference between the values. All right. And then you will try to find out the difference. Okay, this is for the yearly difference. So what is the yearly difference here? Equals to 189,000 minus 134,000, and the value that you get is $55,000. So that means to find out the value in terms of months, it's $54,000 divided by $55,000 multiplied by 12. So that's 11.78 7.8, yeah, 11.78 months. Okay, so if you want to cross check, so equals to your yearly difference divided by 12, we get a value of $4,583.33. So this value multiplied by 11.78 gives you $54,000. So this matches with this. That means your value now is correct. So in this case, your payback period is equals to, so 3 years and 11.78 months. So that is your payback period. All good, everyone? Okay, so I'll give you 5 minutes to try this out and let me know if you have any questions or any queries. You have 5 minutes on you. Any questions, any queries from anyone? No? Anyone still working on this?
So for our project,
Yes.
how we find the depreciation rate?
Okay, for your projects, do not include the depreciation rate. Okay, just like the example we're doing now, do not include the depreciation rate. In fact, for your projects, I would suggest for you to use the payback analysis without the discount rate. The examples that we did in exercises we did in last week's class. That will be easier and also more relevant to a website-based project. Okay. Now, in cases like this is for those things or those kind of machinery or systems that depreciate over time. That means the value keeps on going down. Okay. Now, if you look at a website, generally in that case, it's not a machine, so the value doesn't go down. Okay, it remains the same. Does that answer your question, Janish?
Yes, sir.
Okay. So if any other questions, anyone? Musharat, Monish?
No, sir.
Okay.
So,
All right. If no questions or no further queries, so this is where we'll knock off the class for today on payback analysis. I think we need to do one or more exercises come on the tutorial class. So we will definitely go over at least one or two more exercises and try to get more well-versed with this, because this can be a bit complicated at times. All right, so I'll see you all on Thursday's class. Try to be available for the revision and also for exercises on this. Till then, all the very best for your major project. Take care, stay safe, everyone. Goodbye.